This is a brief demo of our team project. The aim of this project is to implement an intelligent agent for Pac-Man contest. This is an overview of this demo. We will discuss approaches first, followed by the challenges that we faced, and then suggest some possible improvements. There are totally 4 different approaches provided by our team, which are multi-stage heuristics, PDDL, MCTS, and an improved MSH based on rules. For the first method, MSH, it designs one single agent implemented with multiple different stages. Depending on the dynamic environment, it will change the strategy, such as chasing or invading. Another important method is the location inference, used to decide the possible position of opponents using noisy distance. There are 2 advantages of MSH. First, it makes the agent flexible to react under different situations. Moreover, since there is no clear difference between 2 agents, the group war can be observed, which performs well in some games. However, the cooperation is hard and even impossible sometimes. In the real game, 2 agents always tend to choose the same movement. Here, only the invader is implemented with MCTS, because the invader would need more search process to avoid opponents. The evaluation method is also based on feature weight set. This method allows the agent to focus on the small part of the maze, which may accelerate the process. However, it is impossible to predict correctly and simulate sufficiently. When the Pac-Man goes too deep into the enemy set, it sometimes cannot find the way home. PDDL model can generate good and suitable plans for agents. The solution will be produced by online planner. There will be 2 different domain files, namely Pac-Man and Ghost. Using Model Planner, it can correctly model the game and react to the enemy sufficiently. However, the latency due to the network cannot be avoided, and the way to get the solution is totally unknown. This method is an enhanced MSH. The major difference is the role of 2 agents, namely one invader and one defender. This is a response to the same policy of many opponent teams observed through the pre-contest replay. The clear assignment of role achieves better results in pre-contest, which can be seen in the demo. However, the agent can still be trapped by the opponent. Or enter the dead end. It is due to the lack of optimization for specific situation. In this case, when the opponent chooses an unreasonable action, like stop, our agent will be stuck and can't score anymore. Moreover, when opponents are all invader or defenders, our agents also cannot react well. Since the policy is set exactly to be one invader and one defender, agents cannot flexibly change the policy during the game. To solve the above problem, we add some new features to avoid danger when possible. It can be seen from the different actions in these 2 demos. Through all these different approaches, the 2 major challenges are as follows. Due to the unpredictable action of opponent, certain measures are designed to respond to a certain action of opponent may fail. The opponent may not choose the best action, which makes it difficult to react. Another difficulty is that the policy is highly dependent on the map. Even with the same implementation, the agent can have very different performances in different maps. Possible improvements can be achieved from several perspectives. One is that the suitable search method for deeper expansion when choose action, BFS or ASR can both be considered. Moreover, we can also set more specific responses to some certain situations, such as 2 offensive or 2 defensive opponents. The third one is about the weight values. So far, always are adjusted manually. For better performance, Q-learning can be added to get a more effective weight set.